Okay, now we are going into 8.2. Just now, 8.1 is about the adaptations and also the respiratory structure. Now, 8.2, we are going to look at the mechanism. Okay, so that means that it's like the steps of breathing. So breathing refers to the repetitive inhalation and exhalation process. Okay, so we start with this the grasshopper. So how do they take in the air? So you still remember the structures now, you have the spiracles, right? So when inhaling air, okay, they make use of the abdominal muscles over here. So when inhaling, the muscles will relax, and this will reduce the air pressure inside the trachea, and the air will enter into the trachea through the spiracles. So abdominal muscles will contract when the air is exhaled. So this is opposite to it. So what happens is that the air pressure will increase inside the trachea, and this will force the air out of the spiracle. Okay, next is on breathing mechanism of the frogs. So the frogs breathe through the mouth and the lungs while in an active state. Okay, that means when it is inactive, usually it is through the skin. Okay, so during inhalation process, these are the mechanisms which you need um, to mention, okay, when you describe. So when during inhalation, when the frog breathes through the nostrils, so this is the nostrils, okay, the mouth and the glottis are closed. So you can see here the mouth, and where is the glottis? This is the one that will closed. Okay, so the floor of the buccopharyngeal cavity is lower. So this is the floor, lower. Imagine these two close and this one lower. So what will happen is that the cavity here is much larger, isn't it? So now such a big volume, what will happen is that air pressure will be low. Okay, the air pressure is low. The low air pressure in the mouth cavity will draw the air into the buccopharyngeal cavity through the nostrils. So air is being forced in. Okay, being forced in. Low pressure relatively compared to the outside. This one has got higher pressure, so air is being forced in. So when the glottis opens, the nostrils closed. So when this open, the nostril closed and the buccopharyngeal cavity is raised. This one just now was lowered. Now it is being raised, go up. Okay, glottis open. This is glottis, it will open. This one goes up, this one open. So what's next is that the increased air pressure here. Okay, this area is going to push the air here into the next compartment, which is the lungs. Okay, so the increased air pressure pushes the air into the lungs. So that's the mechanism during an inhalation. Sorry, this is the picture. Air is forced into the lungs. All right, do you get the steps? So the first one is that buccopharyngeal cavity is filled with air. So it's talking about this area. So the second part over here is talking about how air gets pushed from the buccopharyngeal cavity into the lungs. Okay, now next is exhalation. When the lungs contract, okay, you see the lungs contract, so that means air is expelled from the lungs. So again, the abdominal muscles is playing the role. Okay, then the elasticity of the lungs themselves. So they don't have the ribs like human beings. So it's the abdomen, the muscles, and also the elasticity of the lung playing the role. So some air is expelled through the nostrils, okay, and then while the rest is mixed with the air in the buccopharyngeal cavity. Some goes out through the nostrils over here. Some will be mixing with the air, the remnant of the air that is here in the buccopharyngeal cavity. Okay, so next is the breathing mechanism of the fish. So again, it's divided into inhalation and exhalation when you are to describe. So it's aided by the mouth movement and the operculum. This is the operculum. That is like the covering of the gills. Remember the 4 pairs of gills is now arched at the gill arched, right? So this will push the water into the mouth, okay, and then pass through the gills, and the ventilation increases the flow of water in the respiratory structure. Okay, next is that, yeah, the dorsal view over here, inhalation and exhalation. So inhalation, during inhalation, the mouth will open. Okay, so the fish mouth is open during inhalation. So the floor of the buccal cavity is lowered. Remember, like the somewhat like the frog just now, right? So, but this is called the buccal cavity. Okay, the floor here is lower. So again, this will reduce the pressure in the buccal cavity. Why pressure reduce? It's because of the volume being increased. So water from the outside, which contains dissolved oxygen, will then enter the mouth because of this. Okay, next during exhalation is that, okay, okay, let's look at this. The operculum opening is closed. Okay, remember the operculum structure is now covering the gills. So at this moment, it is closed. Okay, now during exhalation, the mouth is closed. The floor is raised. The floor of the buccal cavity is raised. So water will enter through the gill lamellae. That means this part over here now, it is forcing it through to go through the lamellae. Okay, lamellae, and then there will be gaseous exchange here, right? Yeah, diffusion, through diffusion. Okay, so at the same time, the operculum muscles relaxed. Okay, so the opercular cavity becomes smaller over here. Okay, opercular cavity becomes smaller. This cavity becomes smaller. The volume of the buccal cavity is reduced. This volume reduced. So pressure in the buccal cavity higher than the pressure outside. High pressure will cause the water to flow through the operculum opening. So this is the only outlet, because at this moment the mouth is closed. Okay, let's see. Okay, next is on in breathing mechanisms of the humans already. Okay, you clear with the one just now, so you try and try to understand and to digest it. Okay, and this breathing mechanisms in human beings, I think you should be familiar with it. Okay, as you have learned it before in Form 3. Okay, inhalation. So here you need to mention the intercostal muscles. Okay, you have the external and the internal intercostal muscles. Okay, so internal, last time maybe you didn't describe it in detail, that it has got the external and also the internal intercostal muscles, but now you have to mention it. So external intercostal muscles contract during inhalation, and the antagonist muscles, that is the internal intercostal muscles, will relax at this time. So what will happen is that the rib cage, okay, this is called the cage, it's like a cage, right? The ribs. So it goes upward and outward. So meaning, okay, at the same time, diaphragm, you still remember these muscles, a piece of muscles over here, it will contract. When it contracts, this causes the diaphragm to move down. That means it flattens. It becomes horizontal. So this step 1 and step 2 causes this thoracic cavity to have a greater volume. Inside has got a greater volume. Okay, you have learned in physics that when volume is greater, what will happen to the pressure? Air pressure, will be decreased, isn't it? So meaning the pressure, air pressure in here compared to the air pressure outside the surrounding, relatively, which one has a higher pressure? Okay, the atmospheric pressure is higher. So what happens is that the air outside will be forced into the lungs. Okay, then during exhalation, what happens? External intercostal muscles will relax while the internal intercostal muscles contract. So that means if you master these steps mechanisms, yeah, well, then this one is just the opposite. Okay, just now moving outward, upward, but this one, the rib cage is moving downwards and also inwards. Diaphragm relax, so it curves up, okay, forming a dome. So both these movements will cause the volume in here, the thoracic cavity, to reduce. Okay, again, the relationship, reduce the volume of air, then the pressure will be increased. Higher pressure here as compared to the atmospheric pressure. So the air inside the lung is being forced out to the surrounding, to the atmosphere. Okay. Now this one, the respiratory structure and breathing mechanisms of humans. Maybe you can look at it. Right, it's like a summary for you. Okay, so this table on the similarities and also the differences. Okay, I think you can appreciate this on your own. Right.